Naming ionic compounds, 5.3. We learned in the last video how to work out the formula of an ionic compound made up of ions. In the first example here, sodium is in group 1, so loses 1 electron to form the sodium 1 plus ion. Fluorine, in group 7, gains 1 electron to form the 1 minus ion. Added together, they give a neutral compound with the formula NaF. In the second example, aluminium is in group 3, so loses 3 electrons to form the 3 plus ion. Oxygen from group 6 gains 2 electrons to form the 2 minus ion. Here we need to take 2 aluminium 3 plus ions with 3 oxygen 2 minus ions to make up a neutral compound with the formula Al2O3. From now on, I will no longer give the diagrams of the ions and shells. I will only draw the stable ions. For example here, Na+, F-, Al3+, and O2-. When naming ionic compounds, there are 3 simple rules to follow. Rule 1. The metal ion keeps its full metal name. So here in NaF, the first part of the name is sodium. Here, potassium, calcium, aluminium, magnesium. Rule 2. The non-metal name ends in "ide". So here in NaF, the second part of the name is fluoride. Here, K2S, sulfide, iodide, oxide, nitride. Rule 3, the metal name comes first. So NaF is sodium fluoride, K2S, potassium sulfide, CaI2, calcium iodide, Al2O3, aluminium oxide, Mg3N2, magnesium nitride. Time for some practice questions. Name the 3 ionic compounds below: BaCl2, Rb2s, LiBr. You should now pause the video until you have named the 3 compounds. I shall give the solutions in the next slide. Please pause now. The compounds are barium chloride, rubidium sulfide, and lithium bromide. Naming transition metal compounds. Transition metals are a little bit different to normal metals in that they can form more than one stable ion. We are going to look at 2 transition metals, namely copper and iron. Copper can form 2 stable ions, Cu1+ and Cu2+. This means that copper can form 2 different copper oxides, Cu2O, CuO. To tell them apart, we state which copper ion we are talking about. Cu2O is made up of Cu1+ ions, so is the copper 1 oxide. CuO is made up of copper 2+ ions, so is copper 2 oxide. Iron can form Fe2+ or Fe3+ ions, so can again form 2 different iron oxides, FeO and Fe2O3. FeO is made up of Fe2 plus ions, so is named iron 2 oxide. Fe2O3 is made up of iron 3 ions, so is iron 3 oxide. Transition metal compounds are often coloured and are largely responsible for the colourful display in fireworks. Mars is red due to the iron 3 oxide on its surface. It is iron ions that give our blood its red colour. Two other transition metal ions, zinc and silver, are worth mentioning here. Zinc only forms the Zn2 plus ion, and silver only the Ag1 plus ion. ZnO, for example, is just zinc oxide. As there is only the Zn2 plus ion formed, there is no need to say zinc 2 oxide. For the same reason, AgCl is just silver chloride. Let's look at a worked example with transition metals. Name the compound CuF2. As all ionic compounds must be neutral, then the charge on the one copper ion and two fluorine ions must equal 0. But is it copper 1 plus or copper 2 plus? Easy to solve, as F is always F1 minus. So that means that one copper ion and two F1 minus ions must equal 0. In other words, copper plus minus 2 equals 0. Copper must be the 2 plus ion. It is therefore copper 2 fluoride. Here is another example. Give the formula of iron 3 sulfide. This time we know the name of the compound and need to work out its formula. We are told that it is the iron 3 plus ion from the name iron 3, and we can work out that sulfur is the S2 minus ion. So that means Fe3 plus and S2 minus ions must combine to give a neutral compound. One of each ion still leaves us with a positive charge. To obtain a neutral charge of 0, we need to take two Fe3 plus ions with three S2 minus ions. This gives the neutral compound and formula Fe2S3. Another practice question. Name the two ionic compounds below, FeBr3, ZnS, and give the formula of the following ionic compounds: copper 1 chloride, silver oxide. You should now pause the video until you have completed the exercise. I shall give you the solution in the next slide. Please pause now. Here are the solutions for the questions in the last slide. If you got these wrong and don't understand why, then I suggest you review the video. Compound ions are last on our list of naming ionic compounds. Compound ions contain more than one different type of atom. They are ions and so can be positive or negative. These are by far the easiest to name, but you'll have to memorize the 5 compound ions. Treat each compound ion like a single ion, e.g. Cl1-. The naming process is easy, as both positive and negative compound ions keep their name. The 5 ions are ammonium, sulfate, nitrate, carbonate, and hydroxide. Best way to demonstrate the naming of compound ions is with examples. Here, NH4Cl, ammonium chloride. N2CO3, sodium carbonate. Ca brackets NO3 close brackets 2 calcium nitrate. Notice in the formula of calcium nitrate we need 2 NO3 1- ions for the 1 calcium 2+ ion. The nitrate ion is placed in brackets. This is to show that it is 2 times the whole nitrate ion. Time for a few more practice questions. Name the 2 ionic compounds below: NaOH, KNO3, and give the formula of the following ionic compounds: copper 1 hydroxide and iron 3 sulfate. You should now pause the video and work out the solutions on a separate piece of paper. I will, as usual, give the solutions on the next slide. Please pause now. Here are the solutions for the questions in the last slide. NaOH is sodium hydroxide. KNO3, potassium nitrate. CuOH is copper 1 hydroxide. And Fe2 brackets SO4 close brackets 3 is iron 3 sulfate. You should now complete the multiple choice test, naming ionic compounds 5.3. As usual, you are free to use your copy of the periodic table.